In this video, we are going to continue talking about the dot product, and I'm going to show you how to find the angle between two vectors. All right, also the relationship of the sign of the dot product to what type of angle we got, okay? So here's what we're going to need for this. So the angle formula looks like this. First of all, it's cosine of the angle between two vectors. It actually is not that hard to prove, but we are not proving it. So it's just going to be the dot product on the top. And then we have the magnitude of each vector on the bottom, okay, multiplied. So once we get that number, and it's going to be positive, negative, or 0, we can then classify the type of angle it is. So if we get a positive number, remember cosine of an angle in the first quadrant is positive, right? So we will know if the dot product, because everything depends really on what's in the numerator, right? Because the bottom is just two positive numbers multiplied, so that's not going to change the answer. So if the dot product is, so A dot B, if it's positive, that means the angle between them is between 0 and 90 degrees, so meaning acute. So angle theta is acute, okay? If the dot product is negative, so if we computed it and we got negative, then if you remember in the second quadrant between pi over 2 and pi, that's when you're going to have a negative cosine, because cosine is the x coordinate, right? So that means the angle will be obtuse. So looking at it graphically, these are your two vectors, A and B. This is vector between, this is angle between them, theta, and so over here, the dot product will be positive. So A dot B positive. But if you have something like this, where this is, let's say, A, and then this is B, it's kind of hard to write that vector is like drunk or something. This right here, this angle is theta, and that's between pi over 2 and pi. So this is where dot product will be negative. So this is obtuse, right? Now, what happens if the dot product is 0? And that's very, very important. So dot product is 0, because we're going to use this all the time. If the product is 0, then cosine of the angle between these two vectors is going to be 0, right? Because again, everything determines the top, right? Everything is determined by the top. And cosine of what angle is 0? Well, that angle is 90 degrees, so pi over 2, right? If you know your trig, you would know that. So it actually works vice versa. So if the angle is 90 degrees, then cosine is 0, which will make the dot product 0. So it's actually if and only if. So this is going to be something that you must remember. In order to check it, to see if two vectors are orthogonal, meaning that the angle between them is 90 degrees, we want to check if dot product is 0. So this is something to know. So when I say check to see if two vectors are orthogonal, what do I want? I want you to compute the dot product, and I want you to see if it's 0. So dot product is 0, angle theta is 90 degrees, which means that vectors are perpendicular or orthogonal. Okay, so let's just note that. And then we are going to proceed with computation in this specific case. Okay, so what do we know in here? Okay, now we can see that A and B are actually not written in using components, because you can see that A and B are written using standard unit vectors, right? IJK, standard unit vectors. So I don't actually like this notation because it makes a lot of people make mistakes. I like the component form. So I am going to transform this form to a component form. But this is something that you have to be very much aware of, because this happens in a lot of tests. Whenever you have a missing standard unit vector, like for example, K is missing or J is missing, you need to understand that that corresponding component will be 0. Okay, and then you have to be careful which one is 0. So in this case, the coefficient of I is 1, which is going to be the first component, right? The coefficient of J is 7, and there is no K. What that means is that corresponding component in A is going to be 0. Okay, with B is not that hard. That one is just 5, 3, and 1. Okay, so first let's determine the dot product, which is just going to be multiplying, right? So it's going to be 1 times 5 plus 7 times 3 plus 0 times 1. Okay, so this looks like it's 5 plus 7 times 3 is 21. So looks like that's 26. Okay, let me just check that. If not, I'll bring up the calculator. No, that looks right. Okay. Next, we also want to find the magnitude of A. Now, with the magnitude, just remember that it's going to be a square root, and then each component is squared. So this looks like it's going to be square root of 50, which you could, make it 5 square root of 2, but I think it's going to take it. So you don't even have to simplify the root. Your teacher will probably, be super happy if you did, but whatever. Okay, so then magnitude of B would be squared the first component plus squared the second component plus squared the last component. Okay, so this is going to be 25 plus 10, so looks to me like that's 35. That one you cannot even simplify. Okay, so now let me show you, once we found that, how do we find the angle? So let me go back to resources. So resources are over here. And then we're going to click on this option, right? Open the calculator in the sidebar because we want it to hover over. All right. So we are going to make sure that the calculator is in degrees because this says express your answer in degrees. So when you look over here, this should be degrees. Okay, that should be highlighted. Then you're going to go to functions. Okay, so you can see this menu right here. That's functions. And then you see the inverse cosine in there. So we're going to click on that. Then we're going to, on the top, we actually want the fraction. So you can go back to main if you want to type the fraction. It's right there. This button right here, or you can use the / of your keyboard. Either way is fine. The dot product should be on the top and the magnitudes should be on the bottom. You can actually bring them under the same root if you want, but whatever. Okay, so then make sure that you round this correctly. By the way, Desmos does have a function round, which makes it super nice. Like if you did not know how to round, it'll do it for you. I hope you do know how to round. I hope that because the 7 follows, that's why this becomes 51.6 degrees. So that's your answer.